huge privilege to be on this panel with these three today, and thank you all for being here and being part of this. I am a committed techno-optimist. I really, really do believe in the power of technology to improve humanity, improve our lives, and the good news is that the stats are on my side, right? When you think about poverty and famine and mortality and even violence, we've all gotten stronger and better and live a more peaceful life. But in that progress and in that march forward, there have also been byproducts, and maybe we didn't consider, or experiences that have arisen as a result of those. And so I think as we start to march through this future, I'd love to navigate sort of through that with you guys. The other thing I think about when we think about technologies on the frontier is the sifting through hype versus reality versus possibility, right? You guys each represent something that's so extraordinary about what our life could look like in the future. And it'll be great to have, hopefully, a really thoughtful conversation. We want to make sure that this time is useful for you all. So if you can think about questions that you might want to ask that I have not asked or they have not asked each other, please do. There is an app, Slido, that we're encouraging you guys to use. And if you haven't used or haven't downloaded it yet, apparently you just go to your browser, go to Slido, and put in South by Southwest, SXSW. But there'll also be a microphone, and we'll toggle back and forth between those in about 45 minutes or so. But first, actually, guys, can you introduce a little bit of yourselves and your work? Just give us a little grounding.
Sure.
Start with you, Adam.
My name's Adam Chayar. The way I define what I'm interested in is as a triangle. So human to machine, how will people interact with computing more naturally? And so I was a founder of a company called Siri, which was really about trying to change the experience and what it's like to interact with computers. So human to machine, human to human. So the question is, how can we harness the collective intelligence of the entire world's population to solve complex, urgent problems? So I was one of the people who helped start Change.org, which is today the world's largest petition platform for good, and trying about 180 million members taking action on making the world better. And so human to human, human to machine, and machine to machine. I was a founder of a company called Sentient, and the question there was, what could we achieve if we had huge numbers of computers and we could pose problems to artificial intelligence at massive scale? Could it help us solve problems that we ourselves couldn't do on our own? And my latest company with some co-founders is called Viv. It really unites all the corners of the triangle into a pyramid. So Viv will be kind of an assistant-like interface. There's definitely very similar to a Siri that you can interact with, but it will be taught by the world. So all of the world's developers can actually come in and add new capabilities, new knowledge, new services, and then there's a lot of machine learning to hold it all together and keep it of high quality. So I think that's what I'm about, trying to help humanity solve complex problems by combining how we work together, work with machines, and how we can help machines help us.
Thank you. Brian.
Hi, my name is Brian Johnson, and I started a company called Kernel recently. And our objective is to gain read, write access to the human brain. And I chose this because it was like a 16-year-long endeavor for me. When I was 21, I returned home after living in Ecuador for 2 years among extreme poverty. And I came home with this burning desire that I wanted to spend my time in life trying to create value for humanity. And so the equation I was trying to answer was, what is the maximum value creation for the species I could create? Like, what is the single thing I could do? And I looked around at the options that I could see in college about working for the United Nations, or Model UN, or going to Africa and helping those who are poor. And nothing really spoke to me as like the operating system level change I thought I could work on. And so I determined that I would become an entrepreneur and retire by 30. And then with abundance of money and time, I would be able to go out and do something. And so it worked, luckily, barely.
Listen up, children in the audience.
And so I thought about that. I mean, almost every day for 15 years, I thought about that question, like, what one thing could I do? And I arrived on human intelligence. And our brain is everything we are, everything we create, everything we'll become. The brain is the epicenter. And humans have always created these tools of intelligence, but humans are just as smart or capable as we have been before. We just have better tools. And it occurred to me that it would be a remarkable and consequential thing if we could gain read-write access to the brain. So I think back to put it in context of technologies that have happened previously to us. So when humans created language, this unbelievable way for humans to cooperate, to use words and sentences and paragraphs. And then when the printing press came about in 1450, we discovered how we can put this in printed format and distribute to the world in these platforms, these tools of creation. And we gained read-write access with software. We could organize zeros and ones to program things. And then we got into biology and complex systems, and now we're building AI. But it's the consequential power of when you have these tools of creation, of what it means for the species. And if we think about the brain, we have 86 billion neurons that talk to each other. And it allows us to formulate thought, to communicate with each other, to have motion, to have memories, experiences. And if we're able to work on that, then we can imagine a future. Well, actually, we can't even imagine a future of what we can achieve. So, Kernel, the purpose of that is to co-evolve with our tools of intelligence. And it's the most epic adventure I think we can imagine as a species.
Until you talk to Reshma.
So my name is Reshma Shetty. I'm a co-founder of a company called Ginkgo Bioworks, and I'm a biological engineer. So I came to biology about 15 years ago, and what gets me excited about it is, usually when people think about technology and some of the most advanced technology they have, they think about this, right? Your iPhone, right, as being, really ubiquitous and a really impressive piece of technology. But there are other technology substrates in this room which actually dwarf anything we can do with computers, which is your cells, right? So human beings, biology is in fact a much more impressive and capable technology substrate than anything we can do with silicon. Biology is capable of manufacturing structures with nanoscale precision. It's capable of continent-wide ecosystems and everything in between. And so why I do what I do is that I'm so excited about biology as a substrate that we could design, that we can engineer, and that ultimately we can program. And if I play that out in my head and think about what possible futures are, I think about how we can transition as a world from a world where we make things, right, manufacture iPhones, to one where we grow everything we need.
Isn't that extraordinary to imagine? And I've had the privilege of having one-on-one conversations with each of these, and you have painted a future that is that I've just never considered, right? And I've spent a lot of time on the edge, more than most. So if you start thinking about the timeline against which you guys are working, right? What is the sort of the timeline, and what are a couple of the key milestones that we can imagine seeing? So Reshma, you want to start?
Yeah, I think about things, I guess, on what is the technology of this century, frankly. If we look at the 19th century, it was about the Industrial Revolution and our ability to sort of manufacture things. If we look at the 20th century, it was all about bits, right? Being able to push zeros and ones around and manipulate them to do interesting things with information. And I think this century is going to return to atoms, but instead of using, chemical engineering or mechanical engineering to manipulate atoms, we're going to use biology, the only self-replicating technology we have to manipulate atoms. And so, where does this go? I think, the ultimate application for, this technology is terraforming Mars, right? If we want to become an interplanetary species, biology is the best way to go and domesticate another planet such that it becomes livable for humans.
Do you have any sense of time around that?
We are really, really bad at predicting timelines for things. So we can imagine things, and those imaginings may even be right on some time scale, but we have no idea when.
Is there any other technology that needs to be convergent with that for that to be possible? Because you guys aren't doing that in isolation, right?
I think some of the technologies that Adam and Brian are working on are going to have a massive impact on our ability to program biology, right? Because frankly, we're really bad at programming biology today, right? We're just in its infancy. And so, we're riding a lot of different technology waves. So one is the sequencing revolution. It lets us be able to read DNA faster and faster and more of the world. There's a similar technology wave around DNA synthesis, our ability to write DNA, right? There's also technologies like mass spectrometry, which lets us measure biological systems and detect what's happening, but also computing, right? And our ability to leverage computational power to design biological systems is going to be hugely important. So, without any one of those, this wouldn't be happening, but the convergence of all of them together is what makes it possible.
Thank you. So Brian, your timeline, what are you working against?
Yeah, there's really exciting things going on in neuroscience now. Neuroscientists have demonstrated that, for example, you can put an interface in the brain and that a quadriplegic can move a robotic arm. So even as few as 10 or 100 neurons can capture of our 86 billion can capture the intent for a person to imagine moving this arm and successfully do it. A few weeks ago, researchers from Stanford demonstrated that a quadriplegic could move a cursor on a screen and type 8 words per minute. And so we've had the feedback loops where if I have a robotic arm and I'm touching something, that the sensation can be fed back into my brain that can create a full loop. And so we have the beginnings where we can understand what neurons are communicating. And it's the beginning of all kinds of things. So if we can understand movement or intent, then you can start imagining what's possible. If we actually could get broader coverage in neurons of the brain, legitimate questions arise, like, for example, could we increase our learning? Could we improve our memory? Could we communicate more efficiently? So, for example, in this room, there's one person speaking at the moment, which is me, which is really a tragedy because there's a lot of brains in this room. What if we could be having a conversation of all of us at the same time? Right? So there's also these questions that arise. And so I think the analogy I contemplate with the brain is, imagine we're in 1450 with Gutenberg, and we have the printing press. And we say, really cool, what kinds of books do you think humans are going to write? And we could probably create a map. Like you could probably say, they're probably going to write really terrible books that say kill each other. And then you're probably on the other side and say, they're probably going to create these beautiful works of art. But then if you go beyond the familiar and you try to map out this other zone, we never, ever would have imagined the kinds of books that have been written over the past couple hundred years. And every single time we have a technology that invites us to imagine. So what kinds of things will people use computer software for? What kinds of things will people use the internet for? Human imagination always fails. So we look at biology, like what kinds of things could we do if we can program biology? What kinds of things would AI do if we could program it? We just don't know. And the brain is the master of them all. It is the creator of our reality. And so when you imagine, like, if we actually could gain access to the brain, if we could understand neurons, if we could write the code in the brain, then we're working with our reality machine, our meaning-making machine. And that's why it's so exciting to me, is basically we're at this point in time. And so these ideas may sound to some exciting, to some a little scary, but that's always the case when new technology comes. And I think that we'll quickly emerge in a time where humans will actively seek this out because we'll have really pragmatic things. It will help us with empathy and communication and cooperation. We'll be able to cooperate more efficiently. We'll be able to learn better. The idea that it takes me 8 hours to read a book is incredibly frustrating. Right? So I've increasingly, as I've
Only 8 hours.
learned in the brain, I guess I spend more time in the brain, I've felt this insane frustration being human and my limitation at how fast I can consume information and learn and communicate and explore.
Right.
So it gets really exciting.
So extraordinary conceptual, but Adam asked you the question in the green room, what is the killer app? So what are a couple of places that we could see it actually start to impact my life on a day-to-day basis?
Right now, as a society, we have a general understanding that people who have a deficiency have the right to technology before everyone else. And so we say, if you're paralyzed, you get access. If you have a stroke or you have a traumatic brain injury, you have access. But if you're a healthy person by our standards, you do not have access. And so it raises this important question on who gets access to technology. And so we've already had a first round of discussions where we found in genetic engineering, you could modify your genome, either an embryo or as an adult. And nation states started having this discussion. And the US said, we're not quite sure about this thing, if it jives with our morals and values. And China said, wow, that's super interesting. Right? So you have like these nation states, and I think our paradigms of understanding what technologies will allow us, and if you look at what's going to happen in the coming years, so AI and automation will increasingly put pressure on humans to differentiate, to do jobs that are taken from them, and to find meaning. And I think you'll find a shift in the human race where we will seek out technologies that make us better and different and find different games of finding purpose in our existence. And so I think it will shift from a deficiency to a normal state, or normal to a
what's your
more
word?
exploratory state.
Oh, ooh, interesting. Okay, I was waiting to see what word
Yeah, I think
you're gonna.
so. One last point on this, then Adam, is I think as we have these debates as a society over these big topics. So we have, for example, civil rights debates, marriage rights, abortion rights. I think the coming debate that will consume humanity will be evolution rights, the ability for a human to opt in or opt out the technologies that could help them improve, genetics, neurological, physical, all the above.
We always talk about the frontiers of law. That'll be an interesting place to play. All right, sir. So your timeline and some of the things that you're really like that you would measure progress against this goal. How?
Well, so regarding timeline, I feel an urgent need to operate right now. And so what we're working on with Viv is really to try to define the next paradigm for how people interact with computing today. And there is a timeline. So if you think 1985, mid-80s, the PC arrives on everyone's desk. 10 years later, almost to the day, the web browser appears, and now everything's different. Every business in the world needs a website. Every connected user needs to be connecting to this thing called web. 10 years later, almost to the year, iPhone emerges and mobile takes out, and now there's this new paradigm for how people interact with computing, right? So everyone now needs an app or a mobile interface. And I don't know if anyone's been looking at the clock, but it's 10 years this year since the iPhone, right? So everyone is starting to ask, is there a next major interface paradigm that's going to change how we interact with computing? And you can tell people are starting to get a little saturated with the mobile paradigm. When's the last time you went looking for, hey, I think I'll download a new app today. What's good? I mean, people
Except when they came to South by and downloaded that and Slido so they could ask a question. Right.
But most people, it's a little bit saturated. They want less apps than more. And so they're waiting for a new way. And we believe that the assistant, if done correctly, can be that new interaction. And we define what we think what it will take to become a paradigm rather than what assistants are today, which is a utility. They use it a couple times, for a few things, but it's not changing anyone's lives. It's not impacting business in a big way. It's not a paradigm.
Well, it probably doesn't understand the questions that I'm asking it
yet. And so now why is that? It's because it doesn't have enough knowledge and it doesn't have enough capabilities. So we think the way to approach that is actually a human AI symbiosis.
Symbiosis, yeah.
In kind of an interesting way, which is developers of the world will be able to teach a new system, new knowledge, new capabilities, and now it will know the things that you're asking. And we're doing it in an unusual way. Today's assistants are really hand-coded by engineers, the use cases. So if you say, what's the weather in Boston? Once you understand the words and the meaning, some developer has said, oh, Boston, I have to go call a mapping server, find all the Bostons, figure out which one it is, then call the weather. That's coded by humans, which isn't scalable. Because if you say, what's the weather at the Super Bowl? Different program. What's the weather at different program?
My sister's house, right.
And so what we're doing with Viv is human developers do what they do great, right, which is define new concepts and actions and microservices. But the flow, the program that gets executed for a user request is actually written by an AI. And that's kind of an interesting thing that you were starting to talk about is how could humans and the brain, because the brain remaps. I've seen cochlear implants. You stick something in, wires into your brain, and the brain learns how to interpret those wires. And software is modulating the signals that get sent to those wires. So there's this interesting, the human's doing some of it, and the brain is doing some of it, and together they're producing a result. And we're taking a similar approach where the human developers are writing some of the content and code, and an AI is actually writing some of the code in this interesting
And then
you know,
the part
way.
that stuck with me when we had this conversation earlier is that it's microtasked against all those computers, right? So there's no dominance of the
That's right.
of
It's
the machine.
distributed much like the web is. Everyone has their own website on their servers, et cetera. But there is an index in the cloud which lets you find and discover them. We have a similar model where every business will have their own content and services. They'll have a website, they'll have a mobile app, they'll have an assistant interface, but there will be this coordinator saying, I need to take this data and send it over here, and I need to, if this comes back, this is what's going to happen. And it's an AI who's trying to achieve the goals on behalf of their user as best as possible.
And what I loved about, and again, I may be really naive as I'm trying to understand all the work that you guys are doing, but there was a risk thing that got reduced when you explained it to me that way. There wasn't the rise of the machine being able to take over and somehow be that much more, again, dominant and extraordinary. Felt like somehow you created a design paradigm that mitigated that.
Right.
Was I naive in thinking that?
So the idea is if human developers can control the flow, and it's an open system, you run into these questions like, well, what if they're a malicious human developer? Could they have access if I say, what's the weather at my sister's house? Do I want the weather provider to be able to call and access who my sister is and where she lives? And so one of the solutions that we've come up with, because the AI is writing the program in a very neutral way, it looks up where my sister is, but then sends just a lat long to the weather provider. It makes this very collaborative effort where everyone does just their small job and is not in control of the entire process.
So it's an interesting question then when I think about the follow-up with Brian, which is that we've become very dependent upon our machines thus far. As I was explaining, I now really have absolutely no navigational intuition anymore because of my Siri. Like I have no idea like what street is east or west or how far. I literally just be turn left, turn right. You'll be there in 11 and a half minutes, usually. So is that a good thing or is that a bad thing? And where do you draw the line? It's not even draw the line, but where do you see the line start to shift, right? Where the technology is enhancing the brain, and at some point the technology is the brain. Does that make sense collectively? Like I'm just trying to figure out how you guys. Right now, the first step is I am ceding more and more of my quote unquote intelligence to a device, right? Is that good? That was Reshma's question to you guys. Like, does that jump in wherever you guys want to? But I just think there was the byproduct. So I will say the first is I'm comfortable giving up some of that intuition because my life is more efficient as a result, right? I get lost less. Now, I also get lost less. I don't get to see a neighborhood that I didn't see before. I don't discover a restaurant that I didn't discover before, right? There's a little bit of my humanity that gets lost a bit in that.
What I think of, if you imagine a calculator, right? A calculator is the simplest piece of technology. What could possibly be wrong with a calculator? Obviously, it performs a task way better than I could do. It's faster, it's more accurate than if I were writing this out hand. So it's perfect, right? But on the other hand, I look at a calculator and I realize my father used a slide rule. And he would look at a bunch of numbers and then say, oh, that calculation is wrong. And people were like, how could that be? I typed in all the numbers. Oh, maybe I mistyped it.
Right.
But he had an intuition of what those numbers felt like.
Exactly.
And when you're using a calculator, even though it's perfect, I've lost something in that. I've taken technology. It's now doing some of the work for me and better.
Right.
And it's trust, but now I'm not doing that work. So is it making me smarter? So what I would say is all technology, I think, does extend and help, and we could not live our lives without a calculator. But there is something lost for everything gained, and you have to kind of weigh those. So I think it's for the better. I wouldn't change it any other way. But interesting to know that, for instance, the intuition of my father's generation with the slide rule, where they're estimating, maybe some of that's lost. At least it is.
Well, I've worked on teams where people then look at that final number and say, well, the number was right because the machine just told me it was right, right? And there is no sense, the logic about should it be higher, should it be lower. So when you start to think about what you're building, how does that?
I think I would reframe the question. And I think, because what you were trying to get at is you're trying to
It took me like 32 minutes to get to the point where you did that. Yes.
I think what you're trying to ask is what and why.
Okay.
Right? So trying to frame like, is it good or bad, or should we not? And that frames people's decisions. I think like, when I think about the brain, like we can tell a few stories. Like we could say, it's really important to work in the brain because we can help address neurodegenerative disease and dysfunction. And so that speaks to me as a human because my stepfather has early signs of Alzheimer's. And so I sit and watch him lose his humanhood, which is devastating. I can do nothing about it. And I suffered from chronic depression for a decade. And so I know these feelings of absolute hopelessness of not wanting to live. And so the desire to build something in the brain to address those things that we all have familiarity with is compelling. And we all say, yes, let's do that. And if you tell a second story and you say, okay, well, recently there's been a strong narrative in society that AI poses a risk. And a few people have grabbed the narrative and said, we should be petrified of it. And that's been this really scary story that people have had to reconcile. Then another camp is formed where they say, actually, no, we shouldn't be scared. But the
Adam's in that camp.
That's right. But the way it relates to the brain is, so the second story is like, okay, so if humans don't co-evolve with AI or humans don't increase their intelligence, then the AI is going to somehow pose this existential threat for the species. And so we have this urgent need to work on the brain. And not only is it urgent, but if you look at the development rate of how fast you can develop AI relative to how fast you can develop in the brain, it's really different. Working in the brain is really, really hard. We have regulatory work, we have ethical and safety considerations, the science is at an early stage. And so one iteration on the brain may take years, up to 10 years to get something to market versus iteration on AI, you can do a lot in a decade. And then the third story is a story of like aspiration. If we say, if you say, what are like the most remarkable things we could do as a species? And in 1960, JFK said, let's go to the moon. And everyone's like, hell yeah, let's go to the moon. Like, what are we gonna do there? We don't know, but hell yeah, let's go to the moon. Right? And so like we choose these things to do because they're epic. And like Shackleton said, I want to cross the South Pole, side to side. That's my epic adventure. And so I think if I were to say like, what is the most epic thing humans could do? Like the number one, to me, it would be the brain. Because we have no idea what's there. And so if you, for example, in our eyes, we experience the electromagnetic spectrum. And the electromagnetic spectrum is like trillions of times bigger than what we experience. And so there's this reality that exists outside of our sensory mechanisms to pick up. So I wonder, like, is consciousness is a possible range of consciousness for our brains a trillion times the size of what we experience today? That's a really interesting question to me. I really want to find out. And so to me, again, if I'm JFK in the 60s or I'm doing the equivalent today, I'm earmarking the brain as the thing that society should be absolutely obsessed about because of this exploratory potential of what we can experience as humans.
So it makes us more human to do this. You know, I'm just saying, I'm just taking it right back down to this. At the end of the day, we become more expansive humans. We become another form, actually, of human when you start to talk about consciousness, right? And what's available to us in terms of a knowing that is bigger that we can see and play with and navigate with.
Yeah, I don't think there's going to be, I think people who try to predict out to, let's say, the year 2050 or 2060, I think it's just impossible. Like you just frankly I was imagining today, like what would it be like to wake up in 2060? Like I don't think I could even understand reality. And I think the reason why is because like if you ask a 7-year-old what it's like to be an adult, the 7-year-old in their mind is going to grab models of familiarity. They'll look at their parents and their friends' parents and school teachers. Like we use models to create the future expectations. And if you now say, if we can indeed gain access to the brain, and we can start working with our ability, this organ that creates our reality, then we really have no idea once we get there what the future may look like.
But to your point, the assumptions that we build and the framing around that I think is a really important part. So there's this interesting conversation that Reshma raised around this idea of that we often think about how to engineer machines to be more compatible with humans, right? And you flip that question in a really different way.
Yeah, I mean, I think, one of the interesting thing about all these technology arcs is it lets you sort of broaden how you think about the world, right? And broaden how you interact with the world, right? So, if I think about biology, like I work a lot with microbes, right? Small little unicellular organisms, something that typically no one ever associates with intelligence, right? Because they're just little things that kind of grow and divide and whatnot. But if you actually look at what microbial communities are capable of, we're understanding now that, microbial communities in the ocean regulate global carbon cycles and whatnot. Now, that's pretty intelligent, right? I mean, that's actually a pretty crazy capability. So I think, by exploring these different technology arcs, you can sort of expand what your notion is of intelligence, expand what your notion is of, therefore, to be human and to be part of this larger ecosystem. So I think when you go down these paths, yeah, there are stories that sort of rain towards the dystopian, but there's also stories and arcs that are perhaps less appreciated, where in terms of the opportunities that you can pursue to not only impact the world but change how you think about yourself.
So this whole question then around ethics, which we can go to in a moment around the technology, but there's also this ethical question that you and I discussed, which is the restraint of our pursuit of these technologies, right? Because we're fearful of things, or because we don't fully understand them, or we're trying to integrate them, is its own choice, and whether or not that is actually even an ethical choice to make, right? When you can imagine all the potential that this has to do extraordinary things for us. But the question that I was also curious about when you talked about, again, the relationship between human and machine is to, again, have the question that you thought literally, should we be thinking about how to change ourselves to be more compatible with machines as opposed to the other way around, right?
Yeah, I mean, I think it's interesting, right? Like, Brian, when you think about the things you do, it's like a lot of your challenges are like thinking about how do I design the machine to be sort of compatible with the human, right? And so that I can insert it into the brain or whatnot. But now that we can read and write biology, there's an equivalent opportunity to think about how do we change biological organisms, ourselves or others, to interact with machines in different ways? Or how do we design machines to take on some of the biological qualities that we normally associate with ourselves or the living world, right? How do we make them have a bigger emotional intelligence or whatnot, right? And so I think while these things have been two parallel tracks for a long time, there's now an opportunity to for them to merge and interleave.
So on the emotional intelligence piece, there's this, again, we talk about intelligence often very mechanically and very computationally, right? But there is this other intelligence. You can call it consciousness, you can call it emotional, you can call it interrelational. So as you start to think about what you're building, right? We always think of AI, or I have grown up thinking about AI as being about being able to do algorithmic things and pattern matching and all that. But there's this much deeper, much more generalized and much more humanistic way. And we saw the movie Her, right? You saw people actually literally fall in love with their technology. How does that factor into what you build? Is that a conscious thing, or is that just part of how how do you teach machines to feel?
Yeah, so it's funny when you mentioned the movie Her. So this was a movie with kind of a Siri-like persona. And when I first saw that movie, the engineer in me could not turn off this little voice. So every single thing that came out of Samantha's mouth, I'm like instantly going, oh, I see what they're doing there, the program and how it works. No, literally, it was very distracting. And so I'm sitting here like trying to disassemble and reverse engineer what this intelligence was, until one moment, which probably no one else noticed in the entire movie, but for me it was an epiphany. At one moment, he's like, okay, good night, Samantha, I'm going to go to bed now. And she looks at him and says, can I watch you sleep? And I was like, why would she say that? There's no informational content that can be derived, right? So it was, literally, it's like, well, the only conclusion I could do is there was an emotional love. And I'm like, oh, I don't know how to do that. And then I turned off that part, and I enjoyed the rest of the movie. No, it's true. But
Since then.
So what I would say, just kind of on that topic, there has been some amazing advances in the last 5 years of AI, extraordinary. Some things that I never thought would happen in my lifetime have occurred, and I've heard other AI people say that. And yet, and I think it's super important to emphasize, the things that we've done in the last few years are extremely narrow, extremely focused. And it really comes from human ingenuity applying statistics and machine learning to a very narrow problem. And today's computers have no ability to generalize, almost none.
That's right.
And so they're incredibly good at playing chess or beating the World Jeopardy champion or AlphaGo or even driving a car. But the chess playing program can't play checkers and can't learn and doesn't know about checkers. And so there are, when people talk about AI and they're afraid of AI, they're going, oh, it's going to become sentient. Well, not only is it not sentient, even though I started a company called Sentient,
So you should know.
they're not able to generalize in the way that any 2-year-old human can do.
Right.
And so there's so little about what we know how to do in AI that consciousness, forget about it, right? Emotion, we're not there yet. We don't even know how to do slight generalizations. So one thing I really want to say to everyone is, yes, AI is incredibly useful. We've made huge strides in the last 5 years where we don't understand a lot of what the magic is that are human, and we're not even close, and most people aren't even trying yet. We don't have an idea how to really address that.
What I think is both extraordinary and I actually even think comforting is that each of you recognize that we're at the very beginning. There's so much we don't know, right? We don't know how it's going to play out with consciousness, and we don't know all the things that biology is going to be able to allow us to create. And you talk a lot about that we don't know exactly how this is all going to. You have a vision of what this can do, but we're so far still from being able to manifest it. I asked Alexa when the cheapest time was to fly to Japan, and she had no idea how to answer that for me, right? But that's the kind of expectation that's being set up, that we want to be able to have those kinds of things, right? Because I could ask my son, and he could go look it up, and in a few minutes give me some sort of answer, right? So there is this expectation. We're getting hyped, and we're getting anticipated, and we're getting excited about what's possible, and yet, we're not quite there yet. But I do wonder then again what Brian, I had never thought about this before, but is what you potentially are building going to be able to help the atoms of the world accelerate that understanding about how the brain processes, emotion and feeling and connection.
Yeah, I think what we all share in common is we are all attempting to read and write intelligence. In biological intelligence, which is a form of intelligence we oftentimes don't give credit to. It's this unbelievable form of intelligence that makes up planet Earth and our entire ecosystem, and then our brains, and then our computational intelligence. And there will be this symbiosis between these. And I think that's what's remarkable about the time and place we live, is that before, humans were subject to their environment. They basically just had to deal with what was delivered to them. And now we live in a time and place where we can increasingly program any kind of world that we can imagine. We can author this stuff in biology, potentially in the brain. We're beginning to demonstrate we have some promise there, and in computational forms. And so, for example, when my 13-year-old and I talk about what he wants to do in life, and we talk about this read-write ability to author life, it's obvious to him that that's the case. That I grew up watching Saved by the Bell, where there's 4 people in school, and they were doing their thing. And he's growing up watching this show where I think Lab Rats, where there's 3 kids in the basement, and this billionaire inventor has these 3 bionic kids in the basement. And my son's asking my 11-year-old, Dad, when can I get my prosthetic legs so I can have superhuman abilities? And this is just how they think. And so I think that we now have this reality where we can increasingly author our existence to these technologies. And I think what would be great is if more people in our society aspired to work on these computational things, these forms of intelligence. And if we had all humans play games, right? When we post to Twitter or Instagram or Facebook, we're playing games of communication and status and power and prestige. And if we had games of contributing to these forms of intelligence, I think it would really help humanity in a place where we could contemplate thriving and solving problems in a different way.
Awesome. We're starting to get questions, and I'm looking at them, and I will say the questions that are coming in that I can see right now are very specific to AI that I think can also be answered in other panels around specifically AI that have to do with being able to, when will we have to have some sort of experience with AI to be productive, employees? We'll expect everyone to be trained in some sort of form of AI, and how will this impact the workforce, right? And the future of work and the future of working, which I think are great questions, and we can get to them. But this is a unique panel in which you get to have these 3 explorers, I will say, on them thinking about the frontier in a different way. So part of me wants to have questions that really kind of push our understanding of this even beyond that. So while y'all are thinking of those questions and putting them into Slido, there is one that's very pragmatic, which is about Samsung's acquisition of Viv and what that makes, how accessible Viv will be. So do you want to answer that quickly?
Sure. So in October, we were acquired by Samsung. Viv's remains. So the question was, with the Samsung acquisition of Viv, will that limit its availability to that platform only, or will we see Viv accessible to us all? As I mentioned, our focus is one assistant across every device to access every service personalized just for me. That's what we try to do at Viv. That's very core to what we do. Viv remains an independent subsidiary of Samsung, and they seem quite open, and they're on the record to saying they want us to be bigger than just Samsung devices. Certainly it'll start there, and it'll be kind of first and best on Samsung, but the announced record is that we really believe in an open vision that Viv capabilities will be available across all devices.
Will that intelligence be able to read the safety and health of that particular appliance and or technology itself? I'm just saying. That would be a good thing for the Samsungs of the world who are making washing machines that could use that. You can also ask a question here live in the room if anybody wants to stand up. We'll have a few minutes for that. So Brian, okay, here's a provocative one. Yay, we got a super provocative question. You see that one at the bottom?
Yeah.
You want to go for that one?
Thank you, Jimmy. Okay, Brian, do you see a potential for class warfare between neural augmented humans and organic humans as the technology gains traction?
Yes.
For sure.
That's the kind of question.
Well, unquestionably, yes. And so what's going to happen is that technology will move forward in the forms of improving humans. And we'll see it in genetics and physical form and neural enhancement. And nation states will largely be a nation state discussion because of the way our governments work. And they will decide based upon their ideological operating systems. So the United States is very Judeo-Christian, which is less likely at the moment to embrace these kinds of enhancements. And countries like China will openly embrace these technologies. And countries will be forced to reconcile with the fact that they will need to be competitive in a global landscape with their humans like everyone else. And so in the end, morals and values will need to be adjusted to accommodate a justification for embracing these technologies full throttle. And certain humans will choose to not engage in doing that, just like we have certain humans who have decided to not participate in technology, the Amish, and others will fully embrace it. And so we will have a differentiation of the human race. And I think in the way the structure, the way the world is structured now with nation states, I think it's inevitable that this will happen. And so at Kernel, we hope to be able to build technologies for the brain that would be accessible to billions. Because we realize this is not a question of if, it's just a question of when and how. And we would like to see a situation where the accessibility is broadly distributed to the greatest number of humans possible as fast as possible. And that in doing so, that as a society, hopefully we could make good decisions together, that between nation states and within nation states. But I think certainly this is a new reality that's going to come faster and be more consequential than I think many of us realize.
I agree with you that will happen, and then it will raise a lot of really provocative questions.
Mm-hmm.
So let's just get to the ethics piece for a moment and sort of talk about sort of the frameworks that you guys use for the work that you're doing. I asked at one point whether or not you guys have any liberal arts people in your world, you know, the philosophers and the writers mm-hmm. and the religious, folks. You talk a lot about the framing, through this. Are you informed by, or do you have counselors in mm-hmm. that space that help y'all?
We do. So we're currently putting together a board of ethicists, an ethics board.
Yeah, there you go.
And we take it very seriously. The team and I, we had like a 3-hour conversation 2 nights ago about this and about what we do as a company. And I was encouraged because the people we have at Kernel are extremely thoughtful about the future of the human race. It's not a blind pursuit of making money or of power or fame. It really is a thoughtful approach on what it actually means to be human in the future. And we started soft circling some ideas that we said that our role in society is to build the most powerful tools we can for this exploration. But it is not our responsibility to superimpose our morals and values on other people. It is a case that we as a society collectively decide how we live. It's an input from all of us. But our responsibility is to make the best possible tools. And so I think the example is like the one laptop per child was a well-intentioned endeavor to give people access to information and processing, and it failed. Then you had Chinese manufacturers who were just pursuing making these phones in a capitalist perspective, and it somehow helped everybody with access to capital and economic freedom. So we hope the same is the case, that if we can distribute this technology broadly to humans, that we hope that our societal systems will generate positive outcomes for all of us.
That is the hope for all of us. You guys on the ethics input/advisory framing for what you guys do? Is there anything you won't do, Reshma, when you start thinking about what you can do with genes? Is there anything, a line you wouldn't cross?
Yeah, so I would say first of all, our field has been engaging with folks ranging from ethicists to anthropologists to various kinds of social scientists for a long time now. So I think even from the very early days, we thought it was important for this to be a conversation that included not only the scientists and engineers, but folks from the liberal arts, and those discussions have been ongoing for at least for as long as I've been in the field, certainly. I would say one of the interesting things about our space is that the tools are actually already pretty freely available. So the tools to tinker around with DNA have been and continue to be more and more democratized and available to folks. And so this is not a technology that you can keep under lock and key by any stretch of the imagination. And so generally, when we have conversations about how to ensure that this technology is being used overwhelmingly for constructive purposes, it's not about controlling access to the technology as much as it's about creating a culture and a community that is trying to use this for constructive purposes. So I'm personally a big believer in the power of culture and to shape how we do things, and that the environment you create can have a huge impact on where technologies go. And so certainly at Ginkgo and in the larger synthetic biology community, we've had very deliberate efforts to create a positive culture and a culture where people understand the responsibility that comes with being a practitioner of this technology, right? We very much believe in the power of it. We think it has the potential to have a huge impact on the world. That's why most of us are at Ginkgo and in this field. And so, but along with that, those possibilities comes a responsibility to see that this technology is deployed as responsibly as possible.
It was interesting years ago when I was in San Francisco and we were talking about the maker movement and maker spaces, and I was just brainstorming or chatting with a friend, and I was like, God, eventually there will be labs. They're just like tech shop, right? Where I can go and I can start to play with these kinds of things. And we looked it up, and there was one called BioCurious. I was like, there it is. It's at the very front end of it, right? But you can imagine eventually that stuff will become more democratized and accessible. And so the ethical framework and inputs.
So at Viv, really what we're trying to do is create the next web browser or smartphone. So it's not, it's really just a better interface. So it's not something to be scared of. It's not anything more than what you can do through a browser or
but it was
a smartphone,
actually,
but slightly interesting ways. So I don't think ethics in that, for this specific problem.
So nothing surprised you when you put Siri out? Because I remember one of the things was you could ask Siri, how should I commit suicide? And Siri would start to tell you all the places you commit suicide, and it shifted and became, actually, here's the number to call for help, right?
Yeah.
But at one point it was like, closest bridge, and she would tell you, highest bridge. No, that was, right? So were you not surprised by the ways people asked questions of Siri and some of the ways in which you had to then?
Certainly. I mean, there's a lot of societal, any response can be taken in different ways. I don't know that particular response, but clearly there are cultural things we need to do to give appropriate responses for every situation and are nuanced. There have been other examples in AI where, images produced by an AI were not culturally perfect and things like that. So there's always issues on any technology. But generally what we're trying to do is provide better access to the data and services that already exist today out. So we don't have a giant ethics board. On AI in general, so there have been a number of fears raised by Stephen Hawking and Elon Musk and others, and they've put together an organization called OpenAI, which they're potentially funding for $1 billion to make sure that the singularity doesn't happen or happens in a way that we're aware of. I think that's fine. I'll quote Andrew Ng, who said, he says, it's sort of like, for me, it's sort of like the Mars overpopulation problem. Someday, Reshma is going to kind of have terraformed Mars. We're all going to move there. It's going to be really crowded. Pollution will happen. It's going to be a disaster. Why aren't you worrying about the Mars overpopulation problem? I made reference that we're so at the beginning of AI, worrying about consciousness or sentience or technology singularity overtaking us is so far out, there's almost nothing to do right now. So that's everyone I know who works in the field more or less has that view
I agree
today.
with you on the big meta side of it, but I do think there are small places where it's starting to impact. And people will literally have conversations about, should I have a baby now? Should I move now? Dear Google, should I do this? Like I was at an event actually, talking to someone from Singularity at Burning Man about whether or not AI becomes our God, right? Do we start to look at it for really, not just default on whether or not those numbers are right, but default about decisions that I'm making in my life. So it's interesting to see how people are readily willing to assume that there's an intelligence that's greater than what is currently in my brain and give you that opportunity to answer, right? So I do think that there are some lines that'll be interesting for you guys as you think through and how you manage. So the question that then brings up is who should be regulating the work that you do? Like what should somebody be regulating what you're up to? Brian. Yeah. Looking at Adam. I mean, right now in the AI world, there are multiple, and then they're growing every day, right? You've got AI 100, you've got the Future of Life Institute, you've got OpenAI, you've got a whole bunch of people that are thinking through the implications of this over the course of at least 100 years, right? Is anybody doing that in your world?
So I think it's a moot point because regulation is a series of controls to shape a technology. But it's not a question of if this technology is going to develop, it's going to be developed. Like humans can't stop this. The train's left the station. And it's just the way in which we manage it because nation states will compete for power and security and prestige with these technologies. And so I think it's
just a wild open world, like literally world.
No,
global?
It's not the wild, wild west, for sure not. It's just how do we be thoughtful about it?
Right.
And nation states will compete on that framework. But it's going to be, what I'm saying is that there's more to the game than just simply regulation.
Right.
Right. We're talking about the future of the human race and what will become and then all the implications of doing that. And to your comment on, will AI become our God? Well, it's interesting because if you think of like the grand narratives that humanity has spun, like what are the most epic stories humans have said? Like why do we exist? Well, religions have done a pretty good job. They're like, hey, look, like if you obey by these rules, like I grew up as a Mormon. And so Mormonism said, hey, if you obey by this rule set, you get this awesome heaven where like people don't die, you live forever, you with all your loved ones, you're not sick, you're happy, you get to have all this creative power. So it's like this fantastic story of like what's possible. And other religions have had other stories. And so I think that this new narrative is emerging among the human race of what is possible by ourselves. And so there's been the religions who have said, here's these stories about what we can do. Then there's been the atheists saying like, it doesn't exist. And then Buddhism kind of is like, has their own thing. I think a new narrative, I think there has never been a better time in the history of the human race for a new narrative to emerge about the human race.
Wow. Which then raises a question that someone just asked, specifically of you, Reshma, that will we, in all the work that you're doing, get to a place where we'll have eternal life? Will we not die?
I was hoping you would ask that question.
That came from someone that came from anonymous.
No, honestly, I don't know. I would even challenge the question asker to say, do we want eternal life? I don't know. There's a fundamental part of biology that's about death and renewal of life. And if you took that away, I think you might be losing some of what the technology substrate is capable of, to be honest. And I don't know, you might lose some of what it means to be human if you took away the experience of death. So I'm not sure we want it, even if it is technologically possible.
This panel, by nature, raises way more questions than it even gets a chance to answer, right? So these questions that are coming through are extraordinary, and there's another one that talks about when we're able to have this technology upgrade, what will make us uniquely us, right? Will we all have the same sort of thing, and will we also start to seem more and more homogenous and less distinct as some of that happens? But I will also say we've only got about 6 minutes left. So in the time that we have left, I'll give you guys each a couple minutes to kind of either pick something that has inspired you in your conversations with each other, or some thought that you want to leave us with that you think is important for us to walk away understanding.
So I would just say, one, I'm a huge optimist in humans. We're a miracle to just be here. The things we do is incredible and not replicated or close to replicated today. But humans are great using tools. And so for me, AI and many of the things we're talking about here are new tools to help us improve as humans, to be smarter, to be more thoughtful, to be more capable. And I do believe the world is being faced by these global problems that no one person in a lab is going to solve. And we need to get better as a species at solving these complex urgent problems. And if we can use the tools of communication, working together better, from AI, machines help us work better, maybe biology. Anything we can use to really get better at global problem solving, I think, is a good thing. It's what's very human. We're going to use these tools, but we really need to do that now because problems are coming and we need to face them.
Right.
Yeah, I would say that, so I've had a series of dinners over the past couple months, usually groups of like 12 to 16. And the discussion is around human and artificial intelligence and the co-evolution of these two technologies. And the way I've framed these dinners is I've said, okay, here's this new technology, and here are the stories that we can tell about this technology. And how do these land on you? Because every time a technology emerges in society, we all tell stories. And these stories serve as blueprints upon which we create. So if I'm an entrepreneur, or I'm a policymaker, or I'm a dad, then we understand ourselves through these stories. And so two things I would want to leave in this discussion is, one is that the brain, if we were to have a discussion, and I've done this 6 times with this group, if I were to say, okay, everybody, we all agree that we would like to have a positive world, one where we wake up tomorrow and we have the kind of world that we desire to have. We don't want a terrible future. Let's list out the problems, the things we care about that contribute to that possibility happening. And so we'd probably go through a familiar list. We'd say, well, let's address climate science, let's work on education, let's make sure our forms of governance are cooperating well, let's make sure there's good security. Like there's like this group of, we all nod our heads like, yep, that's part of our vocabulary. But what I would argue is the brain is not on that list. It never has been, not a single dinner. People do not identify the brain as a consequential thing for the species to focus on. And I would argue it deserves a spot at that table. And the second thing I would argue is that when this becomes a new focus, that the stories we tell about the brain, if we say, oh my goodness, we're all so scared because we're going to be hacked, someone's going to control our brain, right? That's going to be, these narratives will compete for our time. Like you've seen, many people have seen Black Mirror, where they tell many of these stories. And so I would invite us to be extremely thoughtful about the stories we're willing to accept, repeat, and tell about the technology, because how we tell the story about the brain will serve as a blueprint for entrepreneurs, policymakers, and others to build upon. And I think it would be a travesty if we let this go the wrong way. And I'm not saying that it's going to be like this amazing future where everything's going to go right. Like clearly things are going to go wrong, as they always do. But on balance, my bet is that we will be better off than not by doing these technologies.
Thank you. Reshma.
Yeah. If I had to have you take away one thing from what I do and from some of the topics today, it would be that recognize that there are many technology substrates out there and that we've really only worked with a few so far in human history, and that we now have an opportunity to work with a new one, which is biology, right? And that we have a unique ability to learn how to read and write DNA such that we can use biology in ways that we haven't ever had before. And if you think through what that means for our ability to do things, Biology is very good at manipulating atoms, right? Putting pieces, creating new structures, creating new materials, manufacturing in essence, right? And so if we really want to make an impact on how we interact with the world and the footprint we leave on the world as humanity, then we need to think about how to radically re-envision how we make stuff, right? And that can we transition from a world where we build factories and take inputs and convert them to outputs to one where we grow what we need, right? And I don't mean grow as in return to sort of a farming type existence or whatnot. I mean like grow an iPhone, grow a house, grow a chair. These are all things that biology could very well be capable of if we simply get better and better at designing biological systems.
You guys, it's a huge privilege to have you here in Austin. When we talk about narratives, I would like one of the narratives out of South by to be that you bring tremendous thought leaders to this town. So you're flying in this morning and you're flying out this evening. You're barely here, and thank you for being here. But you guys each made the commitment to be part of this conversation. So let's have a really, really big round of thanks to each of you.